3.1, solve linear systems by graphing. So if you did not get to watch the notes yet, since yesterday was Wednesday, I would highly recommend you go do that, because there's certain things in there that we will be using. But one thing that I just want to point out, or well, did any of y'all actually watch the notes yet? Just one? Okay, that's fine. Then I'm going to point this out. So if there is one solution, you won't really need to write this down if you already did the notes because you already have this in there. But one solution is if the lines intersect at one point, and we call this consistent and independent. It has infinitely many solutions. If it is like the same line, essentially, just for reference, and we call that consistent and dependent. Can y'all read this okay, since I darkened it a lot? All right, and then the last option is if there's no solution, meaning that the lines are parallel. Then it is inconsistent. So the way I kind of remember these words is the only time it's inconsistent is if there's no solution. Otherwise, it's consistent. But for the independent and dependent, because that tends to be the part that people mix up the most, if you are independent, you like to do things by yourself. And so you do it as like just one. So one is independent, and then infinitely many is dependent. All right, so this section, we have basically, we're given two equations, and we need to graph the lines, and we're finding the point where they intersect. Okay, and then you need to check that solution in one of the equations to see if you found the right intersecting point. Or well, actually, you need to check it in both, because it'll have to work in both for it to be the case. But usually, as long as it works in one, it's going to work in the other one. So, starting with problems. Graph the system. It says to check it algebraically. That just means to plug the numbers in and check it that way. So number 4, we've got y equals 5x plus 2, and we've got y equals 3x. So if they do not give it to you in slope-intercept form, I would strongly encourage you go to slope-intercept form. While the cover-up method, when it's written in standard form, works for graphing, a lot of times for these problems, it's not going to extend the graph far enough for what you need to see for the point of intersection. So you can check and see if it does, but a lot of times you're going to need to go out like multiple points to get it big enough to fit. I tried to limit and not choose the ones that are like way out, but sometimes it doesn't work. Okay, so I'm going to set up a graph for this. And you may make a graph and you may find out that you didn't make it big enough. So just be aware of that also. If you're using graph paper, you don't really need to label the stuff because every block would be considered one. I will also caution you, I would not recommend counting by anything other than ones when you're doing these problems because it's going to make it really confusing about where the points intersect if you're not careful. Sometimes people do it and they can get it right, but a lot of times they end up getting it wrong if they do that. So, unless you're going to change like both the x and the y to be counted by something different, but all right, so this first line has an intercept of 2, so I put a point there, and then it's got a slope of 5, so up 1, 2, 3, 4, 5 over 1, going up into my problem, But I can also go down 5, back 1. So I'm going to do that. 1, 2, 3, 4, 5. So I'm going to just stop right there for the moment as far as putting points on my graph. Now, I may need to go back and add more potentially as I go, but for right now, that's going to be good. My other graph has an intercept of 0, and then it goes up 3 over 1. Well, I can already tell that it's not going to intersect up top. Okay, do we see that? I'm going up 3 over 1, up 3 over 1. It's going to keep getting farther away from that line. So I'm going to go down 3, back 1, and it just so happens that it's intersecting a point that I already had written there. That doesn't always happen. Sometimes it's going to intersect somewhere random, so which is why I say I would not recommend counting by anything other than ones. Okay, so my point of intersection then is -1, -3. So I'm going to check this. So I would plug in these values for x and y. So -3 equals 5 times -1 plus 2. So -3 is equal to -5 plus 2 is -3. So it's good there. If it's good in one, it really should work in the other, but it's always smart to check both. So the other one would be -3 is equal to 3 times -1. -3 equals -3. So I'm good. But that's what it means when it says to check algebraically. Now, as we go through this chapter, you're going to learn other methods like substitution and elimination to solve these. If you choose to do that method, that's fine too. But if it says like you have to solve by graphing, obviously I need to see a graph. But if you want to check it with another method, that's fine too. 10. Y equals -3x minus 13. And -x minus 2y equals -4. So my top one is in slope intercept. Obviously, that's got a y value that's going down pretty far. So I'm going to obviously have to probably have a pretty large graph on this one. And then this one is not in slope intercept, so I need to move this stuff over. So I'm going to add the x. So -2y is equal to x minus 4. And then divide by -2. Y equals -1/2 x plus 2. So those are going to be my 2 lines of things to graph. So since it's going to be pretty large, I'm going to make it over here on this side just so that my graphs are obviously going to be excessive. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, look at that. Perfect. Okay. So all the way down here at -13, I have a point. I'm going to recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes.
Hey, did Ethan order it?
Do what? I put it. Oh. Hold on. So when I fill out the form, I didn't really think about it, but that's probably filling it out as if it's me, right? It's probably filling out the form as if it's me, right? Okay. So how is she supposed to do that then? Because I put it through for him, not for me. Well, I took him off of the regular one, and I did it as if it was me then. But I didn't think about the fact that it's going to show up that way if I do it. Yeah, but yes, he has. It was one for them. It was pepperoni. Okay. Is there a better way for me to do it if they're ordering it on behalf of? Do you know what I mean? Because like she doesn't have a home room, so why she wouldn't be ordering anyways. Yeah, well, because that's what I was wondering. Instead of doing like the way that we do it when we do the tally mark thing, can we put on there 8 and it automatically shows you that means it's a whole pizza?